Hey guys, can you hear me?
Yes.
Okay.
Yes.
We're just waiting for people to get in. How many were you in the last session, guys?
It was a break, miss.
Yeah, and the session before.
Most of the class wasn't in the session.
Most of
Miss, we were 11. 9 people were absent.
wow, interesting. Okay, so we're just going to start. And I'm going to start by asking you some questions. First, maybe I'll take the attendance first. I will take the attendance first. Abdullah,
Yes, miss.
Adam Ihab, Adam,
Yes, miss.
Ahmed Am.
Yes, miss. Yes, miss.
Okay. Ahmed Sharif.
Yes, miss. Yes, miss.
Iyad is not
Miss, can you
here.
hear me?
Yes, I can.
Miss, can you hear me?
Yes, I can. Farida.
Yes, miss.
Okay. Hamza Khalid. Hamza. Huda. Jomena. Okay. Karma.
Yes.
Yes.
Laura Walid. Laura. Layla. Muhammad Izzat.
Miss, did you call me?
Yes, I called you, Laura. Okay. Muhammad Izzat. Mariam Mu'taz. Omar.
Miss, did you call my name?
Yes, I called your name several times, Hamza.
Yes.
Okay, I'm here.
All right. Ruqayya, she's not here. Ziad Tamer is not here. Ziad Hussein is not here. Zain is not here. And Mona is not here. Wow. Okay. So we're just going to start from where we stopped. We're just going to revise a little bit first. So I'm going to ask you some questions. Can anyone tell me what is the alkali used in as a bleacher and a whitewash for whitewash and bleaching? What is the name of the alkali? Raise your hand if you know the answer. What is the name of the alkali which is used for whitewash and bleacher? Yes, Farida. Do you have a question or do you want to answer?
Answer.
You want to answer?
Yes.
Okay, yes. What is it?
Calcium hydroxide.
Calcium hydroxide?
Calcium hydroxide.
Calcium hydroxide, excellent, which is the lime, right? Okay,
Yes.
thank you, Farida. Now, I want someone to tell me what is the name of the Or what is the use of the weak solution of calcium hydroxide, which is called, let me just say at the beginning, what is the use of the weak solution of calcium hydroxide? Yes, Abdullah.
Yes, miss.
What is the use of the weak solution of calcium hydroxide?
It was used in laboratories.
No, the weak solution of calcium hydroxide. Yes, Laura.
Test for carbon dioxide in breath.
Yes, test for carbon dioxide in breath. Thank you, Laura. Okay, guys. I want to ask you about the change in colors. What is the change of color in the red cabbage juice when we add an alkali to it? What is the change of color? What is the change of color in the red cabbage juice when you add an alkali to it? Omar, please mute your mic. So I noticed some people got in. Muhammad Izzat, are you here?
Yes.
Okay, Mona, did you join us? And Jumena.
Your mic is not working. Mona.
Jumena,
Yes.
are you there? Okay.
Yes, I'm here.
Okay, dear. Yes, yes, Mona. Okay. So who can tell me what is the change in color when you add the red cabbage, when you add an alkali to the red cabbage juice? Yes, Ahmed Amr.
It turns blue.
When you add it to the red cabbage juice, it turns what? When you add it to the red cabbage juice, it turns what? Not the litmus, the red cabbage juice.
It turns blue, miss.
Not blue, no, it doesn't turn
It turns
blue.
blue, miss.
What? Who is saying it
Green,
turns?
miss.
It turns green. When you add the alkali to the red cabbage juice, it turns green. It turns green. Okay, yes, Farida, I saw your answer. It's correct. All right, what about the methyl orange? When you add an acid to the methyl orange, what is the change in color? Yes, Omar. When you add an acid to the...
Yellow.
When you add an acid to the methyl orange.
Red.
No. Yes, Farida. Farida, what is the change of color when you add an acid to the methyl orange?
Yes.
Yes.
Change of color when the acid on the methyl orange.
Yes, when you add an acid to the methyl
It
orange.
changes into acid. It turns pink.
It turns pink. Yes, it turns into a pink color. Okay. What about if I added a neutral solution to the red litmus paper? What about if I added the neutral, please mute your mic, Farida. What if I added the neutral solution to a red litmus paper? A neutral solution like water, for example, to the red litmus paper. Abdullah.
Miss, what was the question? Sorry.
If I added a neutral solution, which like water, for example, to the red litmus paper?
Yes.
Yeah, what will
It
something
will
will happen?
turn blue.
Really? Apparently, guys, you're just raising your hand for the sake to hear your own
No.
voice
No,
during
Miss,
the
I
Zoom
know.
session.
Yes, I know. Miss, I know.
Because so far, a lot of wrong answers. Yes, Jomana, what is the answer?
The same?
What?
It will
can't-
stay the same?
It will stay the same.
It
Thank
will-
you so much. Yes, there is no change in color when you add the neutral solution, whether to the blue or to the red litmus paper, the color will stay the same because the neutral solution is not an acid and it's not an alkali, so it's not going to react with any of the colors of the litmus paper. Okay, guys, tomorrow I will do this again. I will ask about the previous parts, and I want you please to study well. And by the way, you have a quiz next Wednesday on this part. Okay? All right. Now we're going to start from where we stopped. We stopped yesterday talking about
Yes, we stopped the
yes,
methyl
the
orange
and the phenolphthalein, yes, the methyl orange and the phenolphthalein. Let me just go through the indicators again quickly. We said that the idea of the indicators started when the scientists wanted to detect the difference between acids and alkalis in a safe and in an easy way without getting hurt. So this scientist called Robert Boyle is an Irish scientist who realized that the fruit juices are used for the dyeing of the clothes. In the French industry, they were dyeing or giving colors to their garments through the juices of the plants. So he thought about using the same technique to know the difference between the acids and alkalis. So he tried the red cabbage juice, and he realized and discovered that when the acid is added to the red cabbage juice, the juice turns red, and when you add an alkali to the red cabbage juice, it turns green. So this is where the idea of an indicator came. What is the meaning of an indicator? An indicator is a dye which changes its color according to whether the chemical added to it is an acid or an alkali. And most of the times it is made of the plant juices or the plant dyes. Like what? Like, for example, the litmus, and I told you that the litmus have 3 colors. 2 of them are used, the blue and the red color. And we said that when we add an acid to the blue litmus paper, it turns red. And when you add an alkali to the red litmus paper, it turns blue. But if you added a neutral solution to any of them, nothing will happen. Then we talked about, yes, we used this word, which is Arab, in order to make it easier for you to remember the color change in the litmus. We said that Arab stands for acid red, alkali blue. Then we talked about another indicators like the methyl orange and the phenolphthalein. And the methyl orange is also an example of an indicator that when you add the acid to it, it turns pink. And if you added the alkali to it, it turns yellow. While the phenolphthalein, the change in color is that it reacts with the acid and becomes colorless. But if you added an alkaline solution to it, it gives a pink color. Okay, so now we are going to talk about, did you do the homework, guys?
Yes.
I
Yes.
did.
Did you do the homework?
Yes, I did it.
Yes.
Okay, so I want you to open page 25, please. Open page 25. Did I give you? No, sorry, it's not page 25.
It was 24.
Plus
It was 24, yes, it was 24. I want you to open page 24, please. Okay, so the people who sent me the homework, page 24, is Lara Walid, Mona, Ruqayya, Ahmad Amr, Ahmad Sharif, Huda, Adam, Abdullah, Jumana, and Karma. Okay, those are the people who I received their homework. Please, the rest, submit your homework. The homework, again, the ones who sent me the homework are Lara Walid, Mona, Ruqayya, Ahmad Amr, Ahmad Sharif, Huda, Adam, Abdullah, Jumana, and Karma. Okay, please, the rest, I want you to submit your homework. Page 24. Where's page 24? Yes, it's right here. Complete using the words in the box. Some plants, such as red cabbage and black currant, can be used to show if a solution is an what or an alkali. Is an what or an alkali? Yes, yes, Omar.
Acid.
Is an acid or an alkali? Okay, easy one. Okay, the next one, we call a substance which can show if a solution is an acid or an alkali, and we can call a substance which can show if a solution is an acid or an alkali. What?
Miss, can I answer?
You answered the first one. Abdullah?
Yeah, Miss, it was easy.
Indicator.
Indicator. Thank you, Abdullah.
Indicator.
Okay, the next one, we make these indicators by taking out the juice from a fruit or vegetable. This juice is called an what? Because it has been extracted from the plant. The answer is already in the same statement. Jumana, can you answer it? Please, guys, make it quick. What?
Extract.
Extract. Thank you.
Extract.
Thank you, Juman. Okay. Next question. The extract is a substance which becomes a different what in an acid from the color it is in an alkali. It's really easy. Yes, Farida?
D becomes a different color.
Color. Thank you, Farid. Okay. The next one. Litmus is another indicator which what color in an acid solution compared to an alkali solution. In an acid solution, it's red, but in an what solution, it turns blue. Ahmad Amr.
Yes.
Litmus is another
Changes color in an acid.
Yes, changes color in an acid. And the other gap, you're going to write what?
Alkali.
Alkali. Thank you, Ahmed. All right, the next one is the coloring. I'm going to do it quickly. I don't want to waste any more time. Okay, so the next one, you are going to color the solutions. All right, so I'm going to do it quickly. They want us to, yes, this table shows what color some indicators will be in acid and alkali solutions. So right here we have the indicators that they used. They used litmus and methyl orange and red cabbage. What are the colors in the acid solution? When we add an acid to all of them, they will all turn red. Of course, I know that the methyl orange, it says pink, but here they wrote it red. Originally it's supposed to be pink. And what about the colors in the alkali? The litmus will turn blue, the methyl orange will turn yellow, and the red cabbage will turn green. So we're going to start coloring those solutions. Here when they added hydrochloric acid to the red cabbage. Hydrochloric acid to the red cabbage. So an acid to a red cabbage, it will turn red. So we're going to color this. Sorry, we're going to color this solution red. Okay, this is a red solution. Sodium hydroxide with litmus. Sodium hydroxide is an alkali. So when you add it to the litmus, it turns blue. Of course, if you add it to the red litmus. Okay. The next one, Muhammad Izzat, stop playing. Okay. Hydrochloric acid in methyl orange, it's also going to turn red or pink. If you colored it pink, that would be better. Hydrochloric acid in litmus, also it's going to be turned into red. And the sodium hydroxide in methyl orange, it's going to turn green because the sodium hydroxide, it's going to turn yellow because the sodium hydroxide is an alkali, and the color change in an alkali in the methyl orange is yellow. And the last one is sodium hydroxide in red cabbage. The red cabbage will turns green with an alkali. Did you do it this way, guys?
Yes.
Okay.
Yes, sir.
All right, very good. Okay, so now we are going to continue with our lesson. I hope we can finish what we're supposed to finish today so that I can show you tomorrow some of the things in the lab. I'm going to bring some of the indicators and acids and alkalis, and I'm going to show you how we're going to play mainly tomorrow. Okay, so now we know what are the acids and what are the alkalis. We know that we can use an indicator to identify or know the difference between an acid and an alkali. Now, the scientists started to think a little bit in an advanced way. They know that there are two types of chemicals. One is called an acid and one is called an alkali. But they also noticed that the acids, some of them are weak and some of them are strong acids. Weak acids, the one that irritates only the skin, and the strong acids which are corrosives. The same in the alkalis. They realized that some alkalis are strong and some alkalis are weak. So they started to think about the idea of that they should arrange the acids and the alkalis according to how strong they are. They are arranging or putting the acids and alkalis in order, in a specific order, according to how strong and how weak the acids and alkalis are. So a Danish scientist called Søren Sørensen came with the idea of a scale. We can make a scale where we are going to arrange all the known acids and alkalis in it according to their strength. Because as I said before, some acids, for example, we add them in food, we can eat them, we can drink them. So they are weak acids because they do not harm us. While some are very strong, which are the corrosive acids, which can burn our skin or cause a hole in our clothes. And the same goes with the alkalis. So he came with the idea of a scale that he can put the acids and alkalis in a specific order according to their strength. And he called this scale a pH scale. pH stands for power of hydrogen. And you really don't have to understand what is the power of hydrogen now. It's something really advanced that you're going to learn at year 9. Okay, so the
But shouldn't it be POH?
is not, it doesn't, you don't put it in abbreviations, and it's not our problem now, okay? The pH scale, it stands for power of hydrogen. The pH scale has been invented by Søren Sørensen, which is the Danish scientist who made this scale so that he can arrange the acids and alkalis according to their strength. Okay, is it clear, guys?
Yes.
Yes, yes.
Yes.
Do you understand? Okay, so what he did, this is how the pH scale looks like. Okay, I want you to pay attention to what I'm going to say next because it's a little bit confusing. Okay, a little bit. All right. In order to study the pH scale, we are not going to start from the 0 point. We are actually going to start studying the pH scale from the middle of the pH scale, which is number 7. The pH scale starts from 0 and ends at number 14, okay? We are not going to look at those now. We want to start studying the pH scale starting from number 7. Why did I choose number 7 to start studying the pH scale? Because the pH 7, when some chemical, we measured its pH, when we measured how strong it is, and it gives us the number 7, this means that this chemical is not an acid and it's not an alkali. And when I say I can measure the pH scale, yes, you can actually use a specific device that we're going to learn about in the next session. There is a specific device that you can use. You can bring any chemical, and you put this device in the chemical, and you will find a number coming on the screen of this device. This number shows us the strength, the pH of this chemical. Okay, if you find that the reading of this chemical is 7, this means that this chemical is neutral. It's not an acid and it's not a base. It's not an alkali. It's not an acid and it's not an alkali. Okay, so I want you to give me an example that of a chemical or a material that you're going to put this device in and it will give you a pH of 7.
Water.
Water, thank you so much. So if I have a cup of water and I put the pH device, which is called the pH meter, it's called this way, the device is called pH meter. If I put the pH meter in the water, it will give me number 7. This means that this chemical or this is a neutral solution, which means that it has a pH of number 7, okay? If you have any other chemicals, okay, and you have a variety of chemicals. Now I have the pH meter and I put the pH meter in one of the chemicals, and the reading that came up to me is number 3. Number 3 means that this chemical is an acid. Guess what? Any number below 7, so from 0 to 6, it means that this chemical is an acid. If the pH meter read from 0 to 6, gave a reading from 0 to 6, this means that the one or the chemical that you are measuring its pH is an acid. Now you have another chemical and you added the pH meter in it. It gave you number 12. This means that this chemical is an alkali. So any number or any pH number above 7, this means that the chemical is an alkali. So from 0 to 6 is an acid. 7 is a neutral solution. From 8 to 14 is an alkali. Okay, I have to end the session now. We're going to continue tomorrow, guys. We're going to start from this point. You have 2 sessions tomorrow, correct? Right?
Yes.
Okay, so one of the sessions we're going to finish this part, and the second session we're
And
going to
both before the break.
what?
And they're both before the break.
Okay, the first session we're going to continue this part and finish it, and then the second session we're going to play with all the chemicals. All right, so please attend the session tomorrow as it is very important. All right, I'll be seeing you tomorrow, guys. Bye.